You ready for science?
Ready for science.
Cool. Let's do this. Okay. So we're going to measure a lot of stuff today. Okay? You ready?
Ready?
Okay. So we're talking about, you want to read this?
Talking about. Ready?
What does it say?
Conservation
Good.
of matter.
Conservation of matter. That means that when you put two things together, the amount is going to be the same no matter what, even if there's a chemical reaction. Okay? So the way I wrote it is amount of matter stays the same. Okay, you listening? The amount of matter, you remember what matter is? It's the stuff that makes up everything. Okay, so the amount of matter stays the same even when changing form. Okay? Because things can change from solids to liquids, liquids to gases.
Item 1
right?
plus item 2
Yep.
equals items together.
Yep. Plus
Air.
plus air. Yep. So
Plus air.
sometimes you'll get item 1 plus item 2 and it equals everything together.
Using tablets.
And sometimes there's something missing and that's going to be air. That means it evaporated. Okay? Remember we talked about last time we talked about solubility.
Solubility.
Solubility means that stuff can mix together, right? So we're going to do the first one. Okay, we're going to turn on our scale.
Let's return on the scale.
Okay. Now it says 0 grams. Okay, we're going to put this on. We're going to do it without this. Okay, so that's basically 50, right? Now it says
50.
okay, so 50. Our scale is a little bit wonky, so 50 plus, it's basically about 50. I'm going to put in just a little bit more.
97.
I'm going to put in just a titch more so that we're at exactly 100 on this, okay? So we've got, this is just a simple example to start off, okay? There we go. Now it's going over. Okay. So basically we have water is 50 grams, salt is 50 grams, 50 plus 50 equals?
50 plus 50 equals 100.
100, right? Okay, so if we put these together we should have 100 grams.
100 grams.
Okay, which one do you want to pour into which? You want to pour the salt into the water?
Pour your salt into the water.
Okay. All the way. Yep, keep going. There you go. Okay, you want to mix it up. Okay, yeah, you want to try and weigh it? We can weigh it. Let's see where it's at. Basically at 100, right?
103.
It says it's 103 now, huh? We didn't gain anything. But basically you get the idea, right? Nothing else changed. So even when it dissolves in the water, it looks like the salt is disappearing, right? There's not as much salt. There's still some in the bottom that hasn't dissolved. But even when it dissolves into the water, you're still going to have 100 grams because you had 50 grams of salt and 50 grams of water. Does that make sense? Pretty simple?
Does that make sense?
Right. Okay. So that's a pretty simple idea. So that's what we're going to be looking at. Okay. We're going to keep our little stirring stick. Here's a real life example. You like this, huh?
I like this, huh?
Yeah. Okay. We have water plus zip is 230 grams.
30 grams.
Okay, 230 grams.
Orange cream.
It's orange cream. It's Daddy's favorite.
Equals orange. Equals orange cream.
So water
Plus orange cream.
plus the zip fizz powder.
Equals orange cream.
And orange cream zip fizz. You want to shake it?
Zip it. Orange cream zip it.
Shake it, 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 shake it. Yeah. Woo! Shake it, shake it, shake it, shake it, shake it.
shake, 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 shake.
Okay, you want to pop it? Whoa! Did that make any gas?
Smells like orange fruit.
Mm-hmm. What happened when you opened it? Did it make gas?
Did it make gas?
It made gas, huh? Let's see what it weighs. 223.
223.
What?
What?
Because we had water plus the Zip Fizz
Plus the Zip Fizz.
equals 230. And now it's 223. We're missing 7 grams. 7 grams.
7 grams.
Where did the 7 grams go?
Where did 7 grams go?
Gas. Right? When you shook it up, it made a chemical reaction. And it released all the gas. That's why they call it Zip Fizz, huh? Yeah? Is that interesting? So in this one, we would have the 230, but then you would have 7 grams over here of air. Does that make sense? Hey. 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 Yeah, I know, you're so interested in this now, huh? Okay. So we had the 230 with everything together.
223.
Yeah, so these ones over here were 230, and now over here it's 223 and 7 grams, right? So 7 grams of air is what we got out of that one because of the reaction.
Because reaction.
So we always start with 230, and then we always end with the 230. So we always end with the same thing that we started with, right? And that's conservation of matter. Okay, that makes sense?
Does that make sense?
Okay, so we're going to do some more experiments, okay?
More
So 0 first, and then we're going to go water, 153, and a balloon, okay? Wait, let it go. Fingers off. Oh, you changed it to pounds. Okay, so now it's at 158. 158. Okay, and then we have 2 tablets.
2 tablets.
Okay, so there's 164. So we gain 6. Okay. All right. So we have 6 grams of the fizzy tablets. Okay.
Tablets.
If we break it, is that a chemical reaction or physical?
Physical.
It's a physical, right?
Reaction.
But we still have the same amount, right?
Same amount.
Still 164, even if they're broken.
Even if they're broken.
Okay. Do you want to put them into the water?
Into balloons.
And I'll put the balloon on top. You want to put them in there? Cool. Cool. Yeah. Okay. Squeeze it out.
Balloons.
Go.
Balloons.
What's going to happen? Let's go. Okay. Solubility. It's dissolving. It's disappearing. Right? Is this a chemical reaction or physical reaction? Chemical reaction or physical reaction? Wait, what? Chemical reaction or physical reaction?
Physical reaction. Chemical reaction.
For the, it's a chemical reaction with these ones because it's making something new, right? So, wait. I think we're letting it out a little bit. I'm kind of curious to see if we'll see any bit of a difference in the air, but I don't think my scale is strong enough to pick up that small of a difference. So it's at 164, even after the chemical reaction, right? So the fizzy water is 164. If we take the balloon off, I don't think we're going to see a difference. So we let let the air out. Okay? Yeah, it still shows basically the same. But it did release some gas. So there's like 160, let's say it ends up being 163 and a half. So 163 and a half, and then we get like half of a gram of gas. Because we know it let out some gas, right? Sneaky, sneaky. Okay. And then, for our last one, a fun disappearing trick. This stinky, stinky stuff.
Oh, it's fun. It's a trick.
Okay. This was our acetone we had last week, right?
Yeah, last week.
Okay, so we're at 0 grams. We have, 71, 72.
72.
Then here we have 5 grams.
We have 5 grams.
So I weighed out before. This is 5 grams of styrofoam peanuts. So we're going to take these and we're going to dissolve it in there. Solubility.
Solubility.
Okay, so 72 is what we're starting with. Let's write that down. 72. And then we're adding 5 grams of the packing peanuts. Okay. Okay. So if we do 72 and we add 5 grams of packing peanuts, what are we going to get? Is that a lot of peanuts? You think those are going to fit in there? I don't know if we're going to get them all in there.
93.
Yeah, but that's with the cups, though. I did it without the cups. So we can go. These are super light, but they're big. They're not very dense. Huh. What is 72 plus 5? Look. 72 plus 5? What is it? Uh-oh. We lost it. We lost it. Do you want to start? Here, we can do it with the cups. If it's easier with the cups, we can do it with the cups, right? Okay, let's do this then. So unit, 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 unit. There we go. We're going to turn it off and then on. Okay. So acetone, we have 72. You're trying to add them all individually. 72 plus 5 grams equals
76.
It should be 77, but yeah, my scale is not very.
77.
Yep, there it is. There it is. There it is. It started showing it. Okay. So, if we dissolve all of these into this little tiny amount of liquid, it still should weigh the same, right? You ready? You want to put them in? Here we go. Here it goes. Oh my gosh, these ones are going to take forever. Really? No way. These packing peanuts are indestructible. Yeah. These ones are going to take forever to dissolve. Let me grab. Well, that was anticlimactic. It's kind of fun to watch the bubbles, though. All the little tiny bubbles. It's kind of fun. There's lots of little tiny bubbles in there. It's going to take a long time to dissolve. Okay. So, you get the idea, right? Conservation of matter. You get the idea of conservation of matter?
Conservation of matter.
If you put 100 pounds in.
30 pounds in.
If you put the 100 pounds in, you're gonna get 100 pounds out.
100 pounds out.
No matter what. Sometimes it'll come off as gas in the
It
air.
happens like gas in the air.
Does that make sense?
Does that make sense?
Okay. Cool. Good science, bro. Good science, brother. We're just gonna sit here and watch it. It's pretty interesting, though. I like the little bubbles. They're so good. Silly boy.